Good morning, students. Today I shall be recording the revision class for gravitation. As you know that exam is near and sound chapter is not there in the exam, so we should cover those chapters which are there in exam, and afterwards we can resume our sound chapter. So without making any let's start. And as you know, in order to start a revision, the minimum requirements are the books and copy. If anything else is available to you, you can also take those help. But in those copy, all the topics and subtopics should be written serial wise, and we shall be covering each topic and then their subtopic serial wise. And once it's over, we can say that our revision of chapter gravitation is over. There may arise many questions in daily life of a student is that why an object fall downward, why the fruits after getting ripened fall on the surface of earth, why do high tide and low tide occur, what is the force that keeps earth, sun, moon and all other objects bound together, or what is the force that is acting between them. In order to know all these questions, we need to know gravitation, and that we shall be discussing in this chapter. Gravitation force is a force of attraction. Here it is stated that every object will attract every other object, and this is same for both the cases. For example, if our earth attracts moon, then our moon also will attract earth with same force. If moon is being attracted with same force, then why the moon is not falling? So this can be explained from this simple diagram in which the stone is being revolved around, and as it revolves around in a circular path, then it means that it changes its direction at every instant, or we can say that its velocity and acceleration keeps on changing at every point. So here lies the force which keeps the stone center seeking, and that force is called centripetal force. If this force would have not been there, then the stone would have flied in a straight line, and that straight line would be the tangent to the circular path. So same thing can be applied to the case of moon and earth, and also the case of our planets and the solar system. See, now next subtopic is universal law of gravitation. Here the term universal is there because this law is applicable to everything that is present in the universe. What does this law states? This law states that every object in this universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So let us see how. We have two objects A and B. Let's say mass of A is capital M and mass of B is small m. And law of gravitation states that force of gravitation between two objects will be directly proportional to the product of their masses. So product of those masses will be capital M into small m. So force is directly proportional to product of their masses, and it is inversely proportional to the distance between them. Here distance between two objects is d, right? So force will be inversely proportional to the square of the distance between them. Now combining both these equations, we can get that force will be proportional to m into m by d square. Now we have to put one proportionality constant, that is universal gravitation constant g here, and now our formula will be force is equal to g m into m by d square. The SI unit of g can be obtained by substituting the units of force, distance and mass. See here, force, distance and mass. So it will be like Newton meter square per kilogram square, and the value was calculated by Henry Cavendish using a sensitive balance, and he found out that value of g will be 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. Importance of universal law of gravitation. Here are some 4 points that can be seen. That it is the force that binds us to earth, The motion of moon around the earth can be explained by universal law of gravitation. The motion of planets around sun and the tides due to the moon and sun, that can be explained if we know the gravitational law. Next topic is free fall. So when a body falls freely under the influence of gravity, we say that object is under free fall. Right? So what are the things that happens to the body which fall freely? Let us see that. When an object falls freely, the direction of the motion of the object will remain same throughout its motion, and it is under the influence of gravitational force, so the object will be facing an acceleration because of the gravitational force, and that acceleration is represented by small g and named as acceleration due to gravity. The value of that small g or acceleration due to gravity is 9.8 meter per second square. To calculate the value of g or acceleration due to gravity, we know that weight of a body is equal to the force of gravity acting on that body, right? So weight of a body is equal to mass into acceleration due to gravity. It will be equal to small m into g if small m is the mass of that body. Now what is from the law of gravitation, we know that force of gravity acting on that body will be capital G, or the gravitational constant, into mass of the earth into the mass of the object by r square, right? So mg must be equal to G, capital G, capital M into small m by r square, right? So now we can see that small m is there in both the sides, so we can cancel it out and we will be having capital G into capital M by r square. Now putting the value of all this thing, means the value of universal gravitational constant g and mass of earth and radius of earth, we can find out the value of small g or acceleration due to gravity, and we will get that it will be 9.8 meter per second square. Our next subtopic is motion of object under the influence of gravitational force of earth. See, if an object is under the influence of gravitational force of earth, so what are the laws or what are the formulas that we can use in order to calculate everything regarding the motion of that object? Same to the three formulas of kinematics. Those are V equal to U plus at, where V is final velocity, U is initial velocity, A is acceleration and T is time, and S is equal to ut plus half at square, where S is distance, U initial velocity, T time, A acceleration due to gravity, and V square is equal to U square plus 2AS. And here we can see the term A, and while doing the problem that is related to gravitational force, this acceleration will be termed as g, because here the acceleration will be acceleration due to gravity g, and it is equal to 9.8 meter per second square. The value of g or acceleration due to gravity will be taken as positive if the motion of the object is in the direction of the acceleration, and if it is in the opposite direction of the acceleration due to gravity, then g will be taken as negative. Our next subtopics are mass and weight. These two terms seems to be same, but they are actually not same. There is a difference, huge difference between these two. So here are two pictures, and from that only you can come to know there are huge difference between the term mass and weight.